Hey Bengals, this is Miss Timmons. Welcome to Atomic Structure Objective number 3. If you've not done so, go ahead and take a minute and set up your Wix. Make sure you write your objective first and then write each of your questions. Today we're going to be talking about our last objective when it pertains to the atom, and that has to do with how light is produced from the moving of electrons. So in the last video we talked about specifically the electron cloud and where electrons can live in the electron cloud, but in this one we're going to talk about how the movement of those electrons can create light. So a couple things that I want to review from the previous video. First of all, we have force of repulsion. That is where the positive protons will repel each other. They want to move away from each other. The neutrons within the nucleus act to kind of glue it all together, and they kind of help with the attraction between protons. Then you have a force of attraction. This comes from items that have opposite charges. So in this case, you have protons with your positive charge, electrons with your negative charge. They will actually attract towards each other, and this is how the electrons are typically held in the electron cloud because of the attraction to the protons. So forces at work in the nucleus. Let me move the video. In the nucleus, since protons repel each other, the more protons there are, the greater the instability, meaning the greater the radioactivity. So typically elements that have protons, a number of protons greater than 83 will result in a radioactive element. What that means is that that particular element will tend to basically split in half. It decays and becomes two smaller elements. A lot of the radioactive elements that we think of and use of in society include things like uranium and plutonium. In the electron cloud, since protons and electrons attract each other, the greater the number of protons and electrons, the smaller the atom will be, because what happens is the higher number of protons will have a greater pull on the electrons, and it actually causes the space in the electron cloud to decrease even though the mass of the atom is increasing. So let's talk about how atoms produce light. So first, what is light? Light is a photon. Okay, it's considered a packet of energy. So what happens is this photon is released anytime electrons move within the electron cloud. So what is the electron cloud? We talked about this last time, and the electron cloud can be referred to in a number of different ways. A lot of times we're going to refer to it as the electron cloud. Sometimes you might hear of it being referred to as energy levels. That just means it's talking about individual rings around the element. You can also hear it talked about as rings, basically. So the electron cloud is where the electrons will orbit a certain distance from the nucleus, and that orbit determines how much energy that particular electron has. The lower orbits, so the closer you are to the nucleus, the lower that amount of energy is, and then the farther you are from the nucleus, the higher the amount of energy is. So now, when is light produced? So here's what happens. You have an electron, and that electron is moving around around its ring, around its energy level, and it will absorb energy. Okay, when that happens, that amount of energy will cause it to move to another ring. Sometimes that is one ring away, sometimes that's multiple rings away, but it'll move within the electron cloud. Eventually that electron will then emit that energy and go back to its home energy level. When that electron releases the energy, that's called emission. That is when it gives off light. So if that electron is doing that from a ring that's close to the nucleus, it's a low energy light. If it's doing it from a ring that's on the outside, it's a high energy light. So low energy color is considered red. High energy color is considered purple. And we're going to be getting into the parts of the electromagnetic spectrum. Basically, the red just has a smaller frequency, like a lower frequency, and the purple has a higher frequency. So when you have movement electrons, red is produced when electrons move in the lower energy levels, so the ones that are closest to the nucleus. Purple is produced when you have electrons that move on the outside. The nuclear process also produces light. So you have two different things that can happen with the atom. You can have nuclear fission, sorry, didn't mean to go back. Nuclear fission, which is where the atom splits in half. That process of splitting it will create two smaller elements, and it will release some energy in that process. You can also have nuclear fusion, which is what happens in stars. This is energy produced from combining two smaller elements, like the hydrogen atoms in stars, to create bigger elements. And then we have emission versus reflection. We've kind of talked about this a little bit. Emission occurs when an object produces and gives off its own light. And then reflection is when light bounces off of the object. So, for instance, the moon, comets, other planets, we can see them simply because they reflect light. We can't actually see them because of their own light. The only body within our solar system that emits its own light or makes its own light is the sun. And that's true about any star in any solar system, in any galaxy. The source of that light is coming from the star. Anything that you see outside of that is a reflection, so it's a light being reflected off that surface. And that is all for today. Make sure you go back and complete your support item and have your homework ready for your quiz when we start class. Thanks, Bengals.